Welcome to JACS in Conversation. I'm delighted to have today as my guest Professor Lia Addadi of the Department of Chemical and Structural Biology at the Weizmann Institute in Israel. Professor Addadi received her bachelor's and master's in organic chemistry at the University of Padua in Italy. She obtained her PhD from Professor Meyer Lahav at the Weizmann Institute before going on to do a postdoc at the Weizmann, followed by a postdoctoral stay at Harvard University. She commenced her independent career at the Weizmann Institute as a senior scientist and then quickly rose through the ranks of associate and full professor, where she is currently at. On top of that, I'm not sure how she manages it, but she served as head of department, dean of the chemistry department, and dean of the graduate school. She's the recipient of numerous awards and accolades in recognition of her pioneering work in the area of inorganic chemistry, biomineralization. She's a member of the National Academy of Sciences of the United States. She has been the Seaboard, Dorothy Hodgkin, and Rosalind Franklin lectures. Those are 3 different lectures. She has been inducted into the GRC Hall of Fame. Professor Addadi is the recipient of the Aminov Prize of the Swedish Academy of Sciences and the Israeli Chemical Society Excellence Award. On top of all those, she has received the Order of Merit of the Republic of Italy, also known as the Cavaliere della Repubblica, and the Spears Medal of the Royal Society of Chemistry. And last, and certainly not least, from my own institution, the Swiss Federal Institute of Technology, or ETH, she has been awarded the Prelog Medal. She is well known, as I mentioned already, as a pioneer in biomineralization, in effect exploring or studying the crosstalk between crystals and biological systems. So welcome, Lia. I'm glad to have this chance to chat with you about science, life, and chemistry specifically. It's great to have you here.
Thank you, Eric. It's great to be here. Thank you for inviting me. And I recognize that you did all what you could to embarrass me from the start. So I'll try to do my best to answer your questions.
Let me start off. You have a fascinating start in life. You grew up in Italy and was educated in Italy. And I'm curious how you went from there to a citizen of the world, finally ending up at the Weizmann Institute in Israel.
As far as I remember myself, I always wanted to end up in Israel for various reasons. But the passage was a little bit chaotic. I in fact, changed all my life, going from Italy and a very family life to Israel and to totally heterogeneous and different reality. And it's interesting, but I think that the science at the time was what was the anchor that I could hang on to. And this, again, for several reasons, because first of all, because the Weizmann Institute is international. I was not the only one who was different from the others. There were people from all over the world. And then, I discovered one thing that was very, very assuring. And this is that science has its own language. And it is a language that really you can use to bring together and fuse everybody from all parts of the world. And I realized that I had this science. I knew it. I could speak it. And so I could speak with anybody anywhere in the world. And I still, since then, believe that science can be used to bring people together. It can be used as a world language to overcome practically any barriers.
How did you first become interested in this fascinating area of biomineralization?
I got interested. It was just by chance, by serendipity, as usual. I had a poster on my work. I was after my PhD, had a poster close to that of Steve Weiner. And Steve Weiner, who has been my collaborator now for more than 30 years, had a poster on biomineralization, and I just fell in love with the beauty and the complexity of biomineralization, and with all the questions related to it that I thought, with my experience and my interest in crystals and how crystals grow, I could contribute to. I told Steve at that time, I'm going now for a postdoc, but when I'll come back, I'll work with you on biomineralization. And this is what happened.
And there's a clear connection to origin of life, of course. I imagine biomineralization or mineralization was there at the very beginning.
We don't know if it dictated the course of what happened. It was there, certainly, a very long time ago. And we know about it because often mineral is what is left of an organism. So after the Cambrian, Precambrian boundary, that's the first thing that we have left. We don't know of other forms of life. So actually, we always see them associated with minerals, but we don't know how they influenced the origin of life.
Yeah, well, no one will ever know the true origin of life, right? There will only be hypotheses. Since we're talking about education, I'm curious, who were your mentors that were critical to your careers? Who were your heroes? Scientists from the past or contemporaries that you sort of modeled yourself after?
I was very lucky. I had a lot of people who were very important in my scientific career. So starting from those who were really close to me, these were Meir Lahav and Leslie Lazarovich, whom I worked with, and in part I still work with, and who are now my colleagues. And they were an inspiration and an infinite source of deep and free discussions. I learned from them both what is scientific rigor and what is scientific freedom. That is something that I still use with my students. I think that it is one of the most important things. And then, if I go out of my comfort zone of the institute, one other institute that was very, very important for me and for my career is your institute, the ETH. And I had there mentors and heroes who I still love, and my esteem for them is enormous. And I used to visit there for many, many years, and there was a time when Duilio Arrigoni, Jack Dunitz, Anne Prelog, and Ashen Moser were in one floor and had neighboring offices because they were already retired. And it was such a fantastic pleasure to visit there. And I asked them, if you have just a cupboard, I would be glad to be there and spend time with you, because it's such a pleasure and such an inspiration. That was a great time, and they were great to me. And then there is another person that was very important for me, and this is Heinz Löwenstam. the father of modern biomineralization. And he was just a person who stood in front of nature and looked at it and was surprised and investigated it and found all kinds of things that other people did not find. He was the first who found that there is magnetite. We were talking about magnetite before, that there is magnetite in the teeth of the chitons, of the mollusks. And he used to come here because he was Steve's supervisor in his PhD. He used to come here later about once every couple of years to spend time with us. And I think the best compliment I got from him, and maybe from anybody, was when he told me, you know, Lia, you can always surprise me. And that was a huge compliment, because he meant surprise him scientifically. And to surprise such a person meant a lot for me. And when he told me that, I knew that I was on the right track.
That's a good story. Well, you yourself have been very successful and inspiring students in science and academic careers. What's the secret to your success as a mentor?
As a mentor, well, part of it, I said, is to respect your students' freedom to think on their own. There are a lot of people who tell their students what to do. And I think this is not a good way to teach. It's not a good way to grow young scientists.
I was looking through your website some weeks ago, and I was very impressed that for the various research topics that are ongoing in your group, you let the students describe. The students and the postdocs have a little write-up, and it looks
Right.
like it's written by themselves, because they each have their unique style. And so it's consistent with what you're saying now. You let them take the lead in describing their research, where it's been and its future direction. That's quite admirable.
That's right. And when they choose their own subject in the PhD or in the postdoc, we choose it together. Of course, it's not that they choose it and I have no part of it, but we discuss about it. And one of the important things is to guide them in the choice, because they must choose what they are cut for. They must choose what they are really attracted to and best at. So give them the freedom, respect them, but also be with them. I couldn't be one of those mentors that have 50 students. It's impossible for me, because I need to enjoy what they are doing. We work together. We sit for hours at the electron microscope and look at things together. And this, I think, is a good way to do it, because then they say what they think, I say what I think. And in this way, there is a kind of communication that cannot be on the two sides of a table when they come with their copybook and they just said, I did this and I did that.
What advice would you give the current generation of young minds as they chart their own future? It's a complicated world in which I think it's much more competitive than certainly when I was young. And, you know, what advice do you give them to chart through that and create their own niche in science that they're going to be known well for?
you almost said what was in my mind, because the secret is to create their own niche. And if I have to give a general advice, which I don't like to do because each one is a different person, but the general advice would be, don't go after fashionable subjects.
Which is so easy to do, isn't it? It's very easy. It's a very easy trap to fall into, I think.
It's an easy trap to fall into, exactly. And this for two reasons. One reason is that you jump on the bandwagon. So if there is something that is already fashionable, means that other people already have done many important things in it, and you come late. You jump on the bandwagon, so it's very difficult to find something that they haven't thought about or they haven't started. And the other thing is that on the fashionable subjects, there is much more competition. And I honestly don't think that competition does well to science. I mean, a little bit of competition is all right. But if you think of people giving their student works that are given by other groups, leaders to their own students, then a lot of work will just be thrown out, not be worth. And this is a disaster. It's a pity for the group leader, and it's a disaster for the student. So I think that every one of us has found one way or the other what his or her own niche is. And these are the successful scientists, not those who just jumped on the bandwagon.
It's been a while since I heard you talk. I believe the last talk I heard you give was about your early work with cholesterol and crystallization and osteoporosis. I'm curious, is there a certain recent topic in your group that you're particularly excited about that you're working on right now that you would want to share with us?
One of this I mentioned before. There are a lot of topics, but one of them I mentioned before is about the optical materials that are the crystals that are used as optical means in animal eye.
By the way, that was my first click on your webpage. The light and biomineralization. I found that I read through the rest, but that's what I was drawn to initially.
Every case we are looking at is more incredible than the other. So we've been looking at the scallops, so that's what I mentioned before, and then at the crustacean eyes that are different, are a little bit more similar to the fly eyes, but not quite. And now we've been looking at an insect that's called jumping bristletail. And it's an insect that has 5 eyes, and one of them has in it mirror that's made of crystals of xanthin. So we studied how they are made and how they build the mirror and how they interact with light. But the more general and chemical and structural problem that we are facing is why these organic crystals, why these are chosen over all the chemicals that we have in our body. And this is turning out to be extremely interesting because you can understand guanine. Guanine is what is most widespread. Crystals of guanine are those that give iridescence to the fish scales. and they are very, very widespread also in other places, in other animals. But why xanthine? Why isoxanthoterine? All the crystals that we find that are used are purines or pteridines. And then this becomes a problem that we are tackling by optics. So that's physics. We are doing optics on these crystals. We are tackling it by theory, just to try to understand what chemical interactions in the crystal gives rise to these optical properties that make them particularly suitable.
How do we get more diversity broadly defined in the sciences and in chemistry specifically?
First of all, I think that the answer is education. The answer is to get them passionate, to bring them close much earlier. So when you get to the level of the PhD, it's too late already, because they don't get there. You have first to have them there, and then you can insert them in a PhD. So I think that the answer may be a lot of presence in the schools, and try to participate in school activities and single out the youngsters who have the sparkle in their eyes, who are fascinated by it. And on the other hand, once they get there, facilitate them. So what we started, for example, is a program for undergraduates, and it's a specified program for one for Arab undergraduates, and the other one for Ethiopian undergraduates, where we know that we don't have enough participation because they normally don't get on in science. They prefer to go out and work after they finish their undergraduate. And so we bring them in, giving them an award to pay for their schools, what they have to pay for the university, and their obligation is to come once a week at the institute and participate in the research of one group. They can do that in a concentrated manner in the summer or do it once a week. It doesn't matter. It works. We got 5 Arab students, all 5 women who enrolled in a master's program. And this is a double winning situation, because for women it's even more difficult in the Arab culture to go and for an academic career.
Let me finish up by asking you a question. What can JACS do better? And as I take on this job, and I'm still relatively early on in this job, I'm welcoming advice and suggestions as to how to make this journal that is so much at the heart of the discipline we're passionate about, how to make it, how to have continuous success as we evolve with the challenges that we face.
It's a very difficult question when you are asked how to do better something that is already so good. So I think that JACS is very good. So it's there are many things that I love in JACS. One of them is that it is a journal in chemistry, but it has everything in it. And you'll have noticed that a lot of times I hinted at multidisciplinarity being very important in science. And I think that this is what also JACS must pursue and must promote. Multidisciplinarity does it in many ways. I love the perspectives because they are wide open to everything that you can think of, and in an intensive way, not an extensive way. So I don't like reviews that are just lists of all what there is to see and to say. But perspective is something else, because then really you can give a new idea, introduce some new concepts. And this is very much what I like. There is one thing that I don't know, as we said before, with the promotion. So the same thing is also with the journal. Oftentimes, if you submit something that is multidisciplinary, it's very difficult to get it refereed in a good way as easily as it is if you have a manuscript that concentrates on one specific subject. Then you know what the population is, you know what the audience wants, you know what the experts are, and you give it to an expert who gives you an opinion that is perfectly all right and complete. But if you have a work that is multidisciplinary, oftentimes it's very difficult. Oftentimes even the editors don't know how to eat it, because they don't know which kind of referee to send it to.
That's a good point that you raise. That, I think, is where diversity is important. So the current makeup of the associate editor board is quite diverse, including individuals that are highly specialized, as has been traditionally the case in a given area, but also individuals that, as you have just described, are more involved in collaborative ventures at the interfaces of various subdisciplines, polymer chemistry and biological applications, or materials and energy, and the like. So I think the board has evolved in that direction to try to address precisely the problem that you just put your finger on. So Lia, thank you so much for taking this time to talk. It's been great chatting with you and catching up on the science, catching up on your vision for the discipline, catching up on your success and all the wonderful stories that you have to tell in connection with your science. It's been great seeing you again, and I wish you all the best. Thank you.
Thank you, Eric. It's been great to talk to you.